Good morning, students. Today we are going to do the last topic for complex numbers, that is finding the square root of complex number and then studying about complex cube root of unity, which is omega or omega squares. Just now I am going to start with square root of complex number. Now obviously you are familiar with the concept of square root. If you have to find out the square root of a complex number, call it as a plus bi, then obviously you will assume that let the square root of a plus bi be equal to a new complex number, call it x plus yi. I hope this assumption is very clear. Now, as we do it in algebra, that is get rid of under root sign. Now when you get rid of under root sign means you will have to square both the sides of the equation which you have assumed and do the expansion and then equate real and imaginary parts separately and get two equations in x and y. Solve those two equations for x and y and put the values. That is how the complete procedure starts. Now I repeat, a plus bi is equals to x plus yi whole square. Since we have squared both the sides, hence we are getting this. Now doing the expansion with a plus b whole square formula, you will be getting x square plus y square I square, and I square could be replaced by minus 1, hence x square minus y square plus 2xyi. So real part is x square minus y square and imaginary part is plus 2xyi. So equating real and imaginary part in this equation, what do we get is a is equals to x square minus y square and b is equals to 2xy. Now if we solve these two equations somehow, there is no set rule. You all know how to solve substitution, elimination, addition, subtraction. Any method could be adapted by any student and get the values of x and y. Once you get the value of x and y, put it in your assumption equation. That will be final square root of a plus bi. Hence, this is the complete procedure. Now, I am taking a question of exercise 9F. You have to find out in question number 1, first part, square root of 3 plus 4i. So, obviously I have assumed let under root 3 plus 4i is equals to x plus yi. Obviously, square root of a complex number is always a complex number. So, when you are assuming, you will assume it as complex number. Now, squaring both the sides, I have not written. If you want, you can write squaring both the sides because it is understood we are trying to get rid of under root sign. Unless and until the sign is removed, we cannot do the equation solving part. So x square minus y square, this side square root sign removed, and this side when you square it, x square minus y square plus 2xyi by the direct formula a plus b whole square. And I have already explained you, since you are getting plus y square into I square and I square will be replaced by minus 1. So this much is the real part, this is the imaginary part. Now this implies that x square minus y square is equals to 3 and 2xy is equals to 4, which implies xy is equals to 2. Now, I have done it by substitution. I am putting the value of y as 2 upon x in this quadratic expression, and we are getting on left hand side x square minus 2 by x whole square is equals to 3. Now solving this equation, simplifying it further, the quadratic is reduced to biquadratic form. x4 minus 3x square minus 4 equals to 0. Now since this quadratic or biquadratic is the simplest form, I have not done any substitution, that is reducing to quadratic form, but I have simply split the middle term and getting two factors as x square minus 1 x square minus 4 into x square plus 1 equals to 0. This is up to you. You can do it any method for factorization. Now this, if you have equal to 0, product of two factors, obviously by convention x square is equals to minus 1, which will be complex root. But we have assumed x and y to be real. So x square minus 1 not real, therefore this is not the possible answer. We go on to the second assumption, x square is equals to 4 implies x is equals to plus minus 2, y will be 2 by x, that is plus minus 1. Hence substituting the value plus minus, taking common outside the bracket 2 plus I. So under root 3 plus 4i, square root of this is equal to 2 square roots. Obviously you will get plus minus 2 plus I. Hence this is the complete solution for the question.